Okay, Nicholas, this was a very late request for help, but I'll see what I can do here. First thing you have to recognize is that this is the third quadrant. I know that because it says between pi and 3 pi over 2. So if you think about where that is, that must be a third quadrant angle. So what I'm going to do is I'm going to draw my Cartesian grid. I'm going to put a third quadrant angle in. Remember that the angle that you're always going to be referencing is the angle between the ray that you're putting in and the x-axis, the closest x-axis. I put a dotted line here. It says the cosine of this angle, theta, is equal to minus 12 over 13. So cosine, if you remember SOHCAHTOA, is adjacent. So it must be this side, which is minus 12, over the hypotenuse of 13. The thing I need to figure out is what is this opposite side over here? So of course, I'm going to use Pythagoras' theorem for that. Let's call that y, because it's actually along the y-axis. So of course, it would mean that the minus 12 squared plus the y squared is equal to 13 squared. So therefore, y squared is equal to 169 minus 144, which I believe is 25. So it means that y is equal to 5. So this side over here is equal to 5. So now I can know what the sine of this angle is. The sine of the angle, theta, must be equal to the opposite side, which we said was 5. It's actually minus 5. Think about where it is along the negative side of the y-axis. So minus 5 over the hypotenuse of 13 is what sine is. Now they asked us for the sine of 2 theta. The identity for sine 2 theta, if you remember from the various identities that we talked about, is equal to 2 sine theta times cos theta. So that means 2 times the sine of theta was this, so minus 5 over 13, times the cos of theta, which they gave us as being minus 12 over 13. So when you do the math on that, you're going to get, I think, 10, so that's 120 over 169. I hope that helps. That would be your final answer.